Hello students, today let us study one of the simple chapter, that is hydrogen. We know that the hydrogen is a simple element present in the universe and it has got a simple atomic structure, and it is the most abundant element in the universe as well as a principal element in our atmosphere. Now if I consider the hydrogen, we know that the hydrogen is the first element in the periodic table. Even though it is the first element in the periodic table, it is not included in any of the groups. It is not included in the first group or any other groups of the periodic table. Now why it has got a special feature? Now why it is placed separately in the periodic table even though it has got a simple atomic structure? Listen here students, hydrogen, we know that atomic number of hydrogen is 1, and we can write the electronic configuration means I can write here 1s1. Now if you observe this electronic configuration, we can find out here that 1s1 means only one electron is there. In our periodic table there is one group where those elements have got the ns1 outer electronic configuration, and we know that those elements are nothing but first group elements which are called as alkali metals. Listen here students, now if I consider the alkali metals, we know that the alkali metals have got the valence electrons, that is a valence electronic configuration of the alkali metal means we can write it in the form of a ns1 which is similar to that of the hydrogen, that is a 1s1. Listen here students, similar to the alkali metals, we know that they have the highest tendency to donate that electron to reach what a highly stable state. That means whenever they donate, whenever they loses their outermost electron, they forms a unipositive ion. For example, if I consider the first group element like lithium, sodium, potassium, rubidium and cesium, if I consider, all these elements have got a single electron in their valence shell, and those electrons can be donated, thereby they can reach what a unipositive ion form, that is a Li plus 1 state, sodium if I consider Na plus 1 state, potassium if I consider Ka plus 1 state. Now similar to that, the hydrogen also has the tendency to donate that single electron and always it can form what use unipositive ion, that is nothing but H plus 1 ion. It is also called as a proton, because hydrogen contains one electron and one proton. After the loss of single electron present in that, it contains only one proton, therefore the H plus ion is always called what? Proton. Listen here students, the property of this hydrogen is similar to that of what? Alkali metal with respect to the donation of the electrons and also with respect to the formation of unipositive ion. And along with that, if you consider the alkali metals, any of the alkali metal if you consider, always these alkali metals have the highest tendency to form oxides as well as halides as well as sulfides. Any of the alkali metal if you consider, always they can form what? Oxides by combining with the oxygen, halides by combining with by reacting with the halogens, as well as the sulfides by reacting with what? Sulfur. For example, if I consider the oxide, lithium if I consider the first element, lithium always forms what? Lithium oxide, nothing but it is also called as a lithium monoxide. Or sodium if we consider, sodium always combines with oxygen to form a sodium peroxide. Listen here students, similar to that, hydrogen also has the tendency to undergo the reaction with the oxygen, and always whenever the hydrogen combines with the oxygen, it forms the corresponding oxide, and oxide of a hydrogen is nothing but water itself. That is the oxide of a hydrogen anta helidre ನಾವು ಯಾವತ್ತು ಏನಂತ ತಗೊಳ್ಳೋದು ನೋಡಿ, water itself. Listen now, similar to the alkali metals, hydrogen also has a tendency to form a halides by combining with the halogen. For example, if I consider sodium, sodium has the highest tendency to combine with any of the alkali metal if you consider, they combine with the halogen to form the corresponding product, nothing but the corresponding halide is formed. For example, sodium combines with the chlorine to produce what? Sodium chloride. We know that, isn't it? Similar to that, the hydrogen also has the tendency to undergo the reaction with the halogen, resulting in the formation of the corresponding halide. For example, hydrogen, if it combines with the chlorine or any other halogen, corresponding halides are formed means here we know the product formed is nothing but hydrogen chloride. That means properties are exactly similar to that of what? Alkali metals. Along with that, if I consider the alkali metal, it can form readily what? Sulfide by combining with the sulfur. Similarly, hydrogen also has the tendency to undergo the reaction with the sulfur, resulting in the formation of the corresponding product, nothing but hydrogen sulfide. That means almost all the properties are similar to what? Alkali metals. Even though the properties are similar to that of the alkali metal, along with its electronic configuration, along with its tendency to lose the electron like a alkali metal, some of the properties are completely different from that of what? Alkali metal. That means we know that always the alkali metals have got a metallic character. Name itself says alkali metals because they shows which property? Metallic property. Highest tendency is there to lose the electron. Therefore, they can reach what? Highly stable state. But if you consider the hydrogen, okay, always hydrogen is non-metallic in nature. It is a gaseous substance. It doesn't show any metallic character. This is the main difference between hydrogen and alkali metal, even though some of the properties are similar to that of what? Alkali metals. Along with that, if I consider the first group elements, nothing but alkali metal, we know that since the outermost shell contains a single electron, after the loss of that electron, they can reach the highly stable state. Ionization enthalpy of these alkali metals is always very, very less. Amount of energy required to remove that outermost electron is very less in the case of what? Alkali metal. But if I consider the hydrogen, even though it contains a single electron, small sized atom, that is a single electron is there, means the electron is very, very closer to what? Nucleus. Ionization enthalpy of this hydrogen is very, very high compared to what? Alkali metal. That is another difference between the hydrogen as well as the alkali metal. For example, if I consider the first element, that is the alkali metal, lithium. The ionization enthalpy of a lithium is 520 kilojoules per mole. If I consider the ionization enthalpy of the lithium, it is about 520 kilojoules per mole. Whereas if I consider the hydrogen, the ionization enthalpy is very, very high compared to the alkali metal. Lithium 520 means here if I consider the hydrogen, ionization enthalpy for the removal of one electron, single electron present in this atom, the amount of energy required is very high, that is about 1312 kilojoules per mole. Just see the difference. Maximum difference exists in the ionization enthalpy of alkali metal as well as the hydrogen. This is the main difference between what? Alkali metal and hydrogen. That is why the hydrogen is not placed in the first group. It is placed separately in the first period in a periodic table, but it is not included in the first group, even though some of the properties are what? Similar to the alkali metal. Now if I consider this hydrogen, we know that the hydrogen contains a single electron. Always this element has the tendency to gain the electron also. It has the tendency to gain a single electron. Therefore, it can reach what? Noble gas state, nothing but a highly stable state. That is not the octet state, that is always called as a duplet state. We know that the hydrogen 1s orbital in the first main energy level, it contains only one electron. Therefore, to complete its electronic configuration to reach the highly stable state, this hydrogen has the tendency to gain what? One more electron. Therefore, it can reach the stable configuration, nothing but 1s2 configuration. This 1s2 configuration is always called as a duplet configuration. By gaining one electron, it can reach what? Duplet configuration, nothing but noble gas configuration, that is a helium configuration. We know that in the periodic table, always one of the particular group, the elements belonging to one particular group have the highest tendency to gain the electron to reach the highly stable octet state or the noble gas configuration, that is nothing but group 17 elements. Listen here students, the group 17 elements. Now if I write the electronic configuration of the group 17 elements, we have to consider the noble gas. And outermost electron configuration means I have to write now here NS2 and NP5. We know that any of the group 17 elements, if you consider group 17 means they are called as a halogens. Now any of the elements belonging to the group 17, if you consider, they have got this outer electronic configuration. That means 7 electrons are there in the outermost shell. They require only 1 electron to reach the octet configuration, nothing but a highly stable noble gas configuration. Hence halogens have the highest tendency to gain the electron. Similarly, the hydrogen also has the tendencies there to gain what? Electron. Hence property wise tendency to gain the electron is similar in the case of hydrogen as well as the halogens, that is the group 17 elements, to reach what? Stable state. That means it shows the similar property of what? Group 17 elements. Along with that, if I consider the group 17 elements, any of the group 17 element, if you consider starting from fluorine, chlorine, bromine, iodine, etc., all the group 17 elements, okay, always it may be the fluorine, chlorine, bromine or iodine, if I consider, always the group 17 elements exist in a diatomic molecular form. Always they are the diatomic molecules. Fluorine, if I consider, it exists in the form of F2, that is a diatomic molecule. Chlorine, bromine or iodine, if I consider, always they exist in which form? Diatomic molecular form. Similar to that, hydrogen, if I consider, always this hydrogen also exists in a diatomic molecular form, nothing but H2. That means one more property is also similar to that of what? The halogens. Whereas if I consider the alkali metal always exists in a monoatomic form only, isn't it? They are the metallic compounds usually contains the corresponding atoms of that particular metal. Whereas if I consider the hydrogen, that do not exist in the atomic form, always it exists in which form? The diatomic molecular form, similar to that of the group 17 elements, nothing but halogens. That is the second similarity towards what? Group 17 elements. Along with that, if I consider the ionization enthalpy of a group 17 elements, we know that the group 17 element means always 7 electrons are present in the outermost shell, nothing but a valence shell. Very, very difficult to remove the electrons because they have the highest tendency to gain the electron. That means ionization enthalpy of these group 17 elements are always very, very high. That is, if I consider the fluorine, always the ionization enthalpy is very high, that is about 1680 kilojoules per mole. Listen here, if I consider the fluorine, it always the ionization enthalpy fluorine atom, if I consider for the removal of 1 electron, amount of energy required is 1680 kilojoules per mole. Whereas if I consider the hydrogen, the ionization enthalpy is very, very high, isn't it? We know that that is equal to 1312 kilojoules per mole. Whereas if I consider the alkali metal, very less ionization enthalpy. That means with respect to the ionization enthalpy, with respect to its existence, with respect to the tendency to gain the electron, the properties of hydrogen are similar to that of what? Halogens. But if I consider the reactivity of halogens, we know that any of the halogen, if you consider, halogens are highly reactive elements. Always the halogens are highly reactive elements. But if you consider the hydrogen, if you compare the chemical reactivity of a hydrogen with the halogens, reactivity of a hydrogen under normal condition is always very less, very low reactive under normal conditions. But if you consider group 17 elements, always these group 17 elements are highly reactive elements. That means even though some of the properties are similar to that of the alkali metals and some of the properties are similar to that of the halogens, this element, simple element, cannot be placed in the group first because there is a difference in this element as well as the alkali metal with respect to some of the properties. Whereas the hydrogen, if we compare with the halogens, some of the properties are similar, but there are some main difference between what? The hydrogen as well as the halogens. Reactivity wise there is a difference is there, understood? That means halogens are highly reactive, whereas if I consider the hydrogen under normal condition, it is less reactive. Therefore it cannot be placed in the group 17 or it cannot be placed in the group first. Therefore, hydrogen is placed separately in the periodic table as the first element because of its atomic number as well as the simple atomic structure. Followed now students. Now let us consider the isotopic forms of a hydrogen. This hydrogen has the tendency to exist in 3 different isotopic forms. We have to study this now. Already you have studied this in the lower classes. In the high school level itself you have studied 3 different isotopes of what? Hydrogen. 3 isotopes of hydrogen. The first isotopic form of a hydrogen is always called as a protium. It is called as a protium. Listen here students, usually hydrogen means we will consider the atomic number as 1, mass number also as a 1. Understood? Atomic number now 1 and 1, that is the protium. If I consider hydrogen, atomic number 1, mass number is also equal to what? 1 itself. That means it contains 1 electron as well as 1 proton. Clear for you students? Mass number is nothing but a 1 number of proton plus number of neutrons. Protium, if I consider no neutrons in the protium, that means atomic number is equal to what? Mass number H1 and 1. And second isotope of a hydrogen, if I consider, it is always called as a deuterium. Another isotopic forms of a hydrogen, that is called as a deuterium, where the hydrogen with the atomic number 1 and mass number 2. You can see here number of neutron present here is 1. Understood? Therefore atomic number 1, mass number 2, that is called as a deuterium, and this hydrogen in a deuterium form can be denoted by writing capital D also. Understood? Instead of writing H1 and 2, we can straight away represent it by writing what? Capital D. And another isotopic form of a hydrogen, that is always called as a tritium. Now tritium means hydrogen with the atomic number 1 and the mass number 3. You can see here it contains 2 neutrons in that, therefore the atomic number 1 and mass number 3. Clear for you? And tritium can be denoted by writing capital T. We can represent it by writing what? Capital T. Now these are the 3 isotopic forms of what? Hydrogen. That is a protium and deuterium. Protium is usually called as a hydrogen itself. Protium, deuterium as well as the tritium. Listen now students, now the next part actually we have to study is the preparation of a dihydrogen. Since it exists in a diatomic molecular form, hydrogen is usually called what? The dihydrogen. We can name that hydrogen also in the form of a dihydrogen, because always it exists in which form? A diatomic molecular form, that is a H2, diatomic molecular form. Now actually we have to study about the preparation of dihydrogen along with the chemical properties of what? Dihydrogen and uses of dihydrogen. But for this year all those concepts are deleted portions. That is the preparation of dihydrogen, chemical properties and uses, that is a deleted part. The next concept we have to study here is about the hydrides. Listen now students, important concept in this hydrogen chapter, nothing but a hydrides. Listen here, now what are these hydrides? Listen here, the hydrogen has the tendency to undergo the reaction with almost all the elements present in the periodic table except noble gases. We know that the noble gases have got a completely filled outer orbitals, outer shell. That is why always noble gases do not have tendency to undergo the reaction. Therefore hydrogen cannot combine with what? Noble gases, and it can undergo the reaction with almost all the elements present in what? Periodic table. Hence it lead to the formation of various products. By combining with the other elements of the periodic table, hydrogen can form various products. Those products are usually called what? Hydrides. Then what are hydrides? Listen here students, hydrides are the binary compounds. Hydrides are nothing but binary compounds. Binary compounds of a hydrogen with any other element except noble gases. Understood? Hydrides are binary compounds of a hydrogen. Binary is nothing but whenever a compound is formed from 2 different elements, it is always called what? Binary compounds. Therefore hydrides are binary compounds of a hydrogen with other elements. Understood? Now we can consider the hydride of a, that is a hydride means binary compounds, we know that. hydride of oxygen means I have to write now H2O. Hydride of sulfur means I have to write H2S. Hydride of nitrogen means I have to write NH3. Hydride of boron means I have to write BH3. Borane always exists in a dimer form, diborane. Like this, whenever it combines with the other elements, it results in the formation of a binary compound. That binary compound is usually called what? Hydrides. Listen now students, these hydrides, depending on the nature of the hydride, always hydrides are classified into three different types. There are three different types of what? Hydrides. Now, which are those three different types of hydrides? That is, the first type of a hydride is usually called, it is called as Ionic Hydrides. The first type of a hydride is called as Ionic Hydrides. Okay, now Ionic Hydrides are also called as saline hydrides. Ionic or a saline, salt-like. Or that Ionic Hydride is also called as a salt-like hydrides. This is the first type of hydride we have to consider. That is Ionic Hydride, saline hydride or a salt-like hydride. Then the second type of a hydride we have to consider here is covalent hydrides. It is called a covalent hydrides. Now covalent hydrides are also called as a molecular hydrides. Covalent or a molecular hydrides. Then the third type of a hydride is usually called metallic hydrides. And the type of a hydride is called as a metallic hydrides. This metallic hydride is also called as a non-stoichiometric hydrides. Non-stoichiometric hydrides. Okay students, the hydrides are mainly classified into how many types? Three types: ionic, covalent as well as the metallic hydrides. Let us consider now the first type, that is nothing but ionic hydrides. Very important concept you are studying. Listen now, what are these ionic hydrides? Whenever we know that hydrides are nothing but a binary compounds. It is always formed whenever the hydrogen combines with what? Other elements. Now ionic hydride means a binary compound formed when this hydrogen combines with any of the S block element. Listen now, ionic hydride means it is the binary compound of a hydrogen formed by the reaction of hydrogen with what? S block elements. S block means we know that it contains two different groups, first group and second group, nothing but alkali metal as well as the alkaline earth metal. Now when this hydrogen combines with the alkali metal or alkaline earth metal, it results in the formation of what? Ionic hydride. For example, if I consider the simplest alkali metal, lithium, undergoes reaction with the hydrogen under particular condition, resulting in the formation of a product called as a hydride, nothing but lithium hydride. Similarly, the next element, if I consider the sodium, combines with the hydrogen, that means the hydrogen has a tendency to undergo the reaction with the alkali metal like sodium also under particular condition, resulting in the formation of what? Sodium hydride. Along with this second group element also we can consider, that is the alkaline earth metal, that is beryllium. Whenever it undergoes reaction with the hydrogen, always it results in the formation of a beryllium hydride, BeH2, beryllium hydride. Or if I consider the second group element, magnesium, has the tendency to undergo the reaction with the hydrogen. Hydrogen can combine with the magnesium, resulting in the formation of the binary compound called as a hydride, and that hydride formed with the magnesium is nothing but a magnesium hydride. Listen here, all this type, it may be the potassium hydride, it may be the rubidium hydride, it may be the cesium hydride, any of the S block element, if it combines with the hydrogen, the corresponding product, nothing but a hydride formed is always called what? Ionic hydride. Listen here students, any of the ionic hydride if you consider, always the ionic hydrides are crystalline in nature. They are always what? Crystalline in nature, and they are non-volatile. And these ionic hydrides are non-volatile in nature, non-volatile. They are not highly volatile. What is meant by volatile? Easily vaporizable compounds. They are non-volatile means their melting point is always very, very high. Melting point or a boiling point, if you consider in the liquid form, always it is very high. Therefore, always they are what? Non-volatile, not easily vaporizable compounds or hydrides. Understood? Along with that, they are non-conducting substances. Non-conducting only in the solid state. If I consider the lithium hydride solid, it do not have any tendency to conduct the electricity. Understood? Non-conducting. Any of the hydride of the hydrogen with the S block element, if you consider in the solid form, always they are what? Non-conducting. But they can conduct the electricity in their molten state. Okay? In the solid form, they are non-conducting. In the solid form, they are non-conducting. But in the molten form, what is meant by molten form? Melt of these hydrides. Melt is nothing but when we melt this, we will get somewhat thick liquid of these hydrides. That melted form of these hydride itself is called what? Molten form, molten state. Molten state is nothing but a melted form of a particular compound. In the molten form, they can conduct what? Electricity. That means if we subject any of the hydride of the hydrogen of with what? S block elements to the electrolysis process. For example, if I consider the sodium hydride, if it is subjected to the electrolysis process, sodium hydride subjected to the electrolysis process, we know that the electrolysis means always we have to use electrolyte. Now, which is the electrolyte in this electrolysis process? Electrolyte is nothing but a melted form of sodium hydride. Sodium hydride, if I consider in the molten state, it is in which form? Ionic form, Na plus and H minus, ionic form. Therefore, it is called what? Ionic hydride. Once we melt it, bond undergoes the cleavage and gets converted into Na plus and H minus. Understood, students? And it is subjected to the electrolysis process by using the proper electrodes. One electrode acts as a cathode and another one acts as a anode. Understood, students? Now, if I consider this as an anode, positive electrode, and this as a cathode, listen here, during the electrolysis process, always at anode, hydrogen gas will be liberated. At anode, what happens? Hydrogen gas is liberated. We know that any electrolysis process, if you consider anode and cathodic reactions, means it is completely oxidation and reduction process. At anode, positive electrode, that is at anode, always oxidation takes place. What is meant by oxidation? In terms of electrons, oxidation is nothing but a loss of electron. That means hydrogen, okay, it has to lose the electron, therefore it results in the formation of H. Hydrogen, H minus form, just see hydride, H minus form, loses the electron and gets converted into H. Large number of hydride ion, H minus ion is always called what? Hydride ion. Large number of hydride ion undergoes oxidation, resulting in the liberation of which gas? Hydrogen gas. That means this electrolysis process shows that in a hydride, any of the hydride if you consider, that is the ionic hydride, any hydride if you consider, any of these hydrides, that is the first group and second group element, hydride formed with the first and second group element, always in that hydrides, in the ionic hydrides, hydrogen exists as a negative ion, and that negative ion is always called what? Hydride ion. It is in which form? Not in a H plus form, always it is in which form? H minus form. It is conformed by the electrolysis process of these hydrides. During the electrolysis process, hydrogen will be liberated at the anode. This confirms that hydrogen in a hydride, ionic hydride, is in which form? Negative ionic form, that is a H minus form, called as a hydride ion. Understood, students? Now let us consider the reaction of these ionic hydrides with the other compounds. Reaction means these ionic hydrides usually have the highest tendency to undergo the reaction with the water. Any of the ionic hydride, if I consider, they have got a highest tendency to undergo the reaction with the water. For example, if I consider sodium hydride, okay, Na plus and H minus, conformation by the electrolysis process, sodium hydride can readily combine with the water. highest tendency is there to combine with the water. On combining with water, always sodium hydride gets converted into corresponding hydroxide. That is, a sodium hydroxide is formed with the liberation of hydrogen gas. Clear now, students? Now hydrides, these ionic hydrides have the highest tendency to combine with the water, resulting in the formation of the corresponding hydroxides along with the liberation of water, hydrogen gas. Similarly, if I consider magnesium hydride MgH2 combines with the water, resulting in the formation of a corresponding hydroxide, nothing but magnesium hydroxide along with the liberation of water, hydrogen gas. I have not balanced the equation, no need to balance this. Just you have to follow the concept. That means these ionic hydrides have the tendency to undergo the reaction with water at a high rate to give corresponding hydroxides. Along with this, if I consider some of the hydrides, that is the ionic hydrides, for example, if I write lithium hydride, LiH, this lithium hydride can combine with the other compounds also, resulting in the formation of a very important products which can be used for the various reactions. Now, which is that important product formed by combining with the other compound? Listen now, lithium hydride has the tendency to undergo the reaction with the aluminium chloride. Okay, it has a tendency to undergo the reaction with the aluminium chloride. Dimer form also exists in the aluminium chloride, that is a Al2Cl6. In the textbook they have given like that, Al2Cl6, that is nothing but a dimer form of aluminium chloride they have given. No need to write the dimer form only, we can also use what? Monomeric form, that is a AlCl3. Understood? Dimer form means what I have to write? Al2Cl6. Textbook equation is like that. Okay students, it can combine with the aluminium chloride. If you want to write the dimer, we can write like this also, twice. Understood? Now lithium hydride undergoes reaction with the aluminium chloride. Always this reaction results in the formation of very important product, that is nothing but lithium aluminium hydride. Already we know about this lithium aluminium hydride. We know that lithium aluminium hydride is a very powerful reducing agent. It can be used as a reducing agent for the reduction of various organic compounds to get the reduced form of those organic compounds. That means the strongest reducing agent is produced when this lithium hydride undergoes reaction with what? Aluminium chloride, and the product formed here is a lithium aluminium hydride. Strongest, very powerful reducing agent, lithium aluminium hydride. Aluminium hydride. Along with that, it also leads to the formation of the byproduct. Byproduct formed here is nothing but lithium chloride. Just see here students, now you can see here lithium hydride undergoes reaction to give a lithium aluminium hydride. Dimer form if I use, I have to write here what? 2Li, see Al twice. Dimer form if I consider AlH4. 4 into 2, hydrogen if I consider 8, here it is, here I have to write 8LH. Understood? Lithium, that is a 8 lithium atoms should be there. That means 2 are already there. Here I have to write what? 6 lithium chloride. And Cl if I consider 6, 3 2s are 6. The equation is balanced. No need to consider the balanced equation, but you have to write, you have to study here reactant as well as the product. Understood? A very important equation this is. Okay. Then the lithium also has a tendency to undergo the reaction with the other compounds like listen here, this lithium hydride also has the tendency to undergo the reaction with, lithium hydride can undergo the reaction with the borane, BH3. We know that borane means usually it exists in the dimer form. Usually monomeric form is highly unstable, BH3 form usually exists in a dimer form means BH3 twice I have to write. This results in the formation of another product, lithium borohydride, LiBH4. Lithium borohydride is also a reducing agent, not as strong as the lithium aluminium hydride. This is also powerful reducing agent only. Understood? Lithium borohydride. The product name is lithium borohydride. Clear for you students? Now we have studied, we have completed the first type of water, the hydride, which is called as a Ionic Hydride, and the Ionic Hydride is also called as a saline hydride because the they can readily form the corresponding salt whenever it combines with what? Other reagents, as well as saline or salt-like hydrides. Ionic hydrides are also called what? Salt-like hydrides. Now by this we have completed the first type, that is the Ionic hydrides. Equations, only a particular very important equation you have to remember here. Only 3 equations we have written. That is, this they are not given in a textbook, you have to consider this, and the second equation and the third equation given in our textbook. Understood, students? Now I'll consider the second type of a hydride. Listen now. The second type of a hydride, it is always called as a covalent hydride or a molecular hydride. Covalent hydride or a molecular hydride. Covalent hydride. Now what is that covalent hydride? Listen now. Whenever hydrogen undergoes reaction with the p block elements, understood? Whenever the hydrogen combines with the p block elements, always the binary compound formed is called as a covalent hydride or a molecular hydride. Covalent hydride is also called what? Molecular hydride. It is also called molecular hydride. Listen now, whenever the hydrogen combines with the p block elements, p block means group 13 to group 18, all those elements are called what? P block elements, except group 18, hydrogen do not have any tendency to undergo the reaction with the group 18, 13 to 17 group elements, whenever it combines with the elements belonging to 13th to 17th group, always that binary compound formed is called what? Covalent hydride. Listen now, based on the number of atoms, based on the number of atoms as well as the bonding, based on the number of atoms as well as the bonding in a Lewis structure. Lewis structure is nothing but a Lewis dot structure we have studied. Lewis structure we have studied. Okay, based on the number of atoms or as well as bonding in the Lewis structure, these covalent hydrides are mainly classified into 3 different types. There are 3 different types of a covalent hydrides based on the Lewis structure, and those covalent hydrides are called as a electron deficient. First type is called as a electron deficient hydride. Electron deficient covalent hydride. Second type is called as a electron precise covalent hydride. Third type is called as a electron rich covalent hydride. Clear, students? That is, the covalent hydrides are mainly classified into 3 types: electron deficient, electron precise and electron rich covalent hydrides. I'll consider the first one, electron deficient. Already we know that covalent hydrides anta helbekidre hydrogen yavudike combine agbeku, elements belonging to 13th to 17th group elements, isn't it? Now the electron deficient hydride means electron deficient covalent hydride. This is nothing but the binary compound formed when hydrogen combines with the group 13 elements. Whenever hydrogen combines with the group 13th elements, always such a binary compounds are called what? Electron deficient covalent hydrides. Group 13th elements. Listen here, students, the group 13 elements are also called as a boron family, isn't it? All the elements belonging to the group 13 are called as a boron family. Now I'll consider one of the hydride of a boron. The important hydride of a boron is BH3, that is a borane. This is the hydride of a borane. Understood? Hydride of a boron called as a borane. Clear for you? Now hydrogen combines with a boron to give borane. We know that borane usually exists in the form of a dimer, that is called as a diborane. Now if I consider the borane, hydride of a boron, borane if I consider, boron atomic number is 5, isn't it? Atomic number of boron is 5. Electronic configuration if I consider, the electronic configuration of the boron if I consider, 1s2, 2s2, 2p1. Just see here, 1s2, 2s2, 2p1. Outermost valence shell contains how many electrons? 3 electrons. I have to write now those 3 electrons of the boron. Listen here, students. Okay, we are studying about The electron deficient covalent hydride, we have written here borane in the dimer form, and boron 3 electrons are there in the valence shell used for the covalent bond formation with the hydrogen during the formation of the borane. Okay, this is the borane I have written, and you can see here, if I consider this boron after the formation of the covalent bond with the hydrogen, totally how many electrons are there surrounding that boron? 6 electrons, isn't it? We know that Lewis dot structure, whatever we'll write, that always depends on what? Octet rule. That means 6 electrons are there surrounding this boron atom in the borane. It is not the highly stable state, isn't it? It has to reach what? Octet state. To reach the octet state, this boron has to gain how many extra electrons? 2 extra electrons. That means it has the necessity of 2 electrons. It is not in a completely octet state. It is now, boron in a borane is now in a electron deficient state. Hence it has a tendency to gain what? 2 electrons to reach the octet state. That is why this is the hydride of hydrogen with the 13th group element, boron I have written. Okay, binary compound only. Since the central atom has got a electron deficiency to reach the stable state, it is always called what? Electron deficient covalent hydride. Any element of the 13th group, if you consider, always the central atom, nothing but the particular element belonging in the 13th group is in which state? Electron deficient state, and always that element has a tendency to gain what? Pair of electrons to reach the octet state. Dear students, you have studied this. A substance, if it has the tendency to gain a pair of electron, listen here, boron as such do not have any tendency to gain 2 electrons. Boron in this hydride form has the tendency to gain, highest tendency to gain what? Pair of electrons, 2 electrons. We have studied a substance, if it has a tendency to gain a pair of electron, is always called as a Lewis acids. Understood? They are always called what? Lewis acids. Hence, all the electron deficient covalent hydrides are what? Lewis acids. Clear, no students? If I consider the aluminium, any hydride if you consider, always they are called what? Lewis acids, because they have the tendency to gain a pair of electron to reach the stable state. Therefore, electron deficient covalent hydrides are formed whenever hydrogen combines with what? Group 13 element. Clear, no students? Hope you have followed this. Now next I will consider the electron precise covalent hydrides. Electron precise covalent hydride, second type, that is nothing but electron precise covalent hydrides. Okay, electron precise covalent hydrides. Now what are electron precise covalent hydrides? We know that covalent hydride means always hydrogen has to combine with the p block elements starting from 13th to 17th group elements, isn't it? 17th group. Now electron precise means whenever hydrogen combines with the group 14 elements. Okay, whenever the hydrogen combines with the group 14 elements, whatever the covalent hydride will get, covalent, all these are covalent hydrides because the sharing of electrons takes place. Therefore, they are called what? Covalent hydrides. Hence, whenever the hydrogen combines with the group 14th elements, the corresponding binary compounds are called as electron precise covalent hydrides. Precise, that means these hydride contains required number of electrons. They are in which state? Highly stable state. Understood? Whatever the electrons are required to reach the highly stable state, that electrons, those number of electrons are present in these hydrides. Therefore, they are called what? Electron precise hydrides. Group 14 elements anta nanu helide alva. Group 14 elements are also called as a carbon family. That means all the elements belonging to the group 14 are called as a members of the carbon family. Carbon, if I consider hydride of a carbon, we know that total number of valence electrons in a carbon are 4. 4 electrons are there. Once the hydride of carbon is formed, 4 hydrogens combines with the carbon to give a corresponding hydride, covalent hydride. I'll write now one hydrogen, sharing of electron, covalent bond, another hydrogen, sharing of electron, covalent bond, one more hydrogen, sharing of electron and covalent bond. Again here it is a hydrogen, sharing of electron, covalent bond formation. And if I consider this carbon atom now in this hydride, you know the name of this organic compound, nothing but a methane. This is called as a hydride of carbon only. Understood? Methane is called what? A hydride of a carbon. Understood? Now total number of electrons, if you consider, how many electrons are there? 4 plus 4 during the sharing of electrons. Totally 8 electrons are there surrounding this carbon atom in its hydride. Therefore it is called as a electron precise. That means a sufficient number of electrons are there. Therefore this hydride is always in which state? Highly stable state. Therefore it is called as a covalent hydride. Which covalent hydride? Electron precise covalent hydride. Any element of the group 14 if you consider, always we will get the structure like this only for the corresponding hydride, and sufficient number of electrons are present in that. Therefore whelectron precise hydride. Understood? No. The last type, that is the electron rich hydride. Now what is this electron rich hydride? Listen here students. Whenever the hydrogen combines with this hydrogen combines with the group 15th to group 17. Understood? Whenever the hydrogen combines with the elements belonging to group 15th to group 17, always that results in the formation of the covalent hydride, and those covalent hydrides are called what? Electron rich. I'll start from the group 15. Group 15 means it is a nitrogen family. First element of the group 15 I'll consider, that is a nitrogen family. Understood? No. Nitrogen, you know the total number of valence electrons present in the nitrogen. That is the 5 electrons. Isn't it? A group 15 elements always have got a 5 valence electrons. Now nitrogen I have written, whenever the hydrogen combines with the nitrogen, it has to produce its own hydride, nothing but a binary compound. I'll write now covalent bond here. Hydrogen, nitrogen can form maximum of how many covalent bond? 3. Isn't it? It can reach which state? Octet state by forming the covalent bond with the 3 other elements only. That means here 3 atoms of, that is 3 atoms of the other elements. Understood? That means if you consider this nitrogen, totally 8 electrons are there. 2, 4, 6 and 8. But all the electrons are not involved in a bond. Already I told you that based on the total number of electrons and based on the bonding in a Lewis structure. How many types? 3 types we have written like this. And if you consider this one, 8 electron state is there. But this nitrogen if you consider, central atom if you consider, it is in which state? Electron rich state, because 2 of the electrons are not used for the bond formation. Those 2 electrons remains in a free state. These electrons are nothing but a lone pair of electrons, freely available non-bonding pairs. They are also called as a non-bonding pairs. Since these hydrides contains free electrons, lone pair of electrons, those hydrides are always called what? Electron rich hydrides. Understood? Group 15 element I have considered. Now I'll write another hydride, that is a group 16 element I'll consider. Group 16 means the oxygen family. Understood? The hydride of oxygen means, we know that oxygen contains how many valence electrons? 6 valence electrons, isn't it? And this oxygen has a tendency to form how many covalent bonds? 2 covalent bond. By the formation of 2 covalent bond itself, it can form the stable compound. I'll write now one of the hydrogen, sharing takes place, covalent bond. Next hydrogen, sharing takes place, covalent bond. I have written the hydride of oxygen, binary compound, whatever this is. If you observe this, 8 electron state is there. But still 2 pairs, nothing but 4 electrons are in the free state. This oxygen is in which state? Electron rich state in a water molecule. These electrons are called what? Lone pair or a non-bonding pairs. Since it contains a free electrons, this hydride of oxygen, nothing but water, is which type of covalent hydride? Electron rich covalent hydride. It is not electron precise, electron rich covalent hydride. It is called as electron rich covalent hydride. Clear for you? Group 16 element are considered. Listen now students, now I will consider the group 17 elements. Group 17 means halogens. The first halogen, that is a Fluorine, first halogen, I'll consider the fluorine. Halogen means totally always they contains how many valence electrons? 7 valence electrons, isn't it? Now 7 electrons are there. It need only 1 electron to reach the highly stable octet state. This fluorine, during the formation of a hydride, it combines with only one hydrogen atom, resulting in the formation of what? A covalent bond. Now if I consider H bond with the F, nothing but HF, hydrogen fluoride I have written. Hydrogen fluoride is the hydride of what? Fluorine. Understood? Hydrogen fluoride is the hydride of a fluorine, and if you consider this hydride of fluorine, only one covalent bond is there. How many pairs, lone pairs of electrons are there here? 3 pairs. That means this complete hydride is in which state? Electron rich state. Understood? Therefore, it is always called what? Covalent hydride, since it involves the covalent bond, or molecular hydride. But which type of covalent hydride? It is a electron rich covalent hydride. Understood, students? Electron rich covalent hydride. Now we have completed the second type of a hydride of a hydrogen, nothing but a covalent or a molecular hydride. Based on the total number of electrons, based on the bonding in a Lewis structure, covalent hydrides are mainly classified into how many types? 3 types. Which are those? Electron deficient, electron precise, electron rich. Electron deficient means whenever it forms the hydrides, that is the hydrogen, whenever it combines with the group 13 element, always that hydride has got an electron deficiency, it always acts as a Lewis acid. Whenever the hydrogen combines with the group 14 elements, sufficient number of electrons are there and totally all the electrons are involved in the covalent bond, it is called as the electron precise covalent bond. Group 14, methane we have studied example. Then electron rich means whenever the hydrogen combines with the group 15 to group 17. Group 15, nitrogen, ammonia we have studied. Hydride of a nitrogen is nothing but ammonia. Group 16, hydride of a oxygen is nothing but a water we have studied. Group 17, hydride of a fluorine we have selected, that is nothing but a hydrogen fluoride. All these hydrides are in the electron rich state since they contain the free electrons or a lone pair of electrons. They are called as the electron rich covalent hydrides. By these students, we have completed 2 different types of hydrides, ionic and covalent hydrides. The last type of hydride we have studied here is metallic hydrides or a non-stoichiometric hydrides. Dear students, hope you have followed the concept which I have explained now. The remaining part I will explain in the next session. Thank you.